Hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and today's project is going to involve a little bit more work on my tracked anvil or anvil shaped object. As I'm sure most of you are aware, an anvil has, pretty much all anvils have two holes. One is a square hole, which is called the hardy hole, and then a round hole, which is the practical hole. Today we're going to work on some tools to go in the hardy hole. And again, if you're not familiar with what that's for, the hardy hole allows your anvil to be a holding device. Not only something that you can pound on, forge on top of, but it can hold your work. Off camera, I made one hardy hole tool. It's got a 3/4 inch square shaft on the bottom. This is a piece of square 3/4 inch square stock that is, there's a threaded rod between these two pieces. Then this is a tapered cone, 1.5 inches, 1 3/4 down here. And what that's for, got a hot piece of metal. You can set that in the hardy hole. You can start forming down here on your horn. But to make that as close to round as feasibly possible in a forging situation, you would use something like this forging cone, where it's round and again got two static up here and tapered down to 3/8 of an inch. If you're a blacksmith, you might want to turn this video off now, because what I'm going to do, I'm not going to forge any of the hardy tools I make. It's all going to be done on the lathe and on the mill. So it's not true blacksmithing by any means, or not true forging. But I'm going to make the hardy tools, so hopefully I can do a little bit of forging on the anvil. Let me pull the, the first thing I want to do, I've got two more pieces of this 3/4 inch square stock cut off, and they don't need to really be any longer than what will go through the hole to the bottom of the anvil. Anything more than that is just weighs stock down. So we're going to mount these in a collet, one of them at a time, of course, in a collet, and go to the lathe, face off one end, drill, and tap for 1/4 20. Okay, since I only have a couple of these pieces to do, I didn't put the collet chuck on the lathe. What I did was just take this hexagon collet block, mounted it in the 5C collet, which I do have some square collets, mounted it into 3/4. And we should be able to face it off now. Now with the piece faced off, we use the center drill. This, of course, is the tap drill for 1/4 20. This will be a blind hole, but I do want it to be deep enough so I got plenty of thread in there, just for holding purposes. Now we're going to start with a 1/4 20 2-flute spiral tap. This is one I like to use whenever I can get my hands on these. The 2-fluted spiral taps seem to have a lot more strength to them than the standard taps. All right, we'll slow down. A little rapid tap. And let it pull itself in. Now we'll finish off this blind hole with a 4-flute bottom and tap. You see there's very little taper on the end of this. And that'll cut those extra 3 or 4 threads down to the bottom. Just clean up the burr on that thread. All right, I'm going to do the same thing to the other piece. Then we'll meet over on the mill and start doing our work over there for the pieces that will actually mount on this Hardy plug. I'm going to actually be making 2 Hardy hole tools today. The first one is going to be a bottom swage, and in it, let's see, this is a piece of about 2.5 by 3 by 3/4 inch thick. Just a piece of hot roll I had over in the material bin. But it's going to be a hole in the center of it with a countersunk screw head that this will screw onto. Then there's going to be 2 slots cut in here, one with a 1/4 inch ball end mill and the other with a 3/8 inch ball end mill. I'll come back later at another time with another piece of material and make one with a couple more sizes, probably a 1/2 inch and maybe a 5/16. Of course, now the reason I don't put all these grooves in one piece, what this swage will be used for, this piece will be put on there with a vane or something that needs to be formed in this slot that we're going to mill out. And I want the surface on each side of that to be flat. So I can't put a whole lot of grooves in there. I've got 1.5 inches in between each one. The second Hardy hole tool we're going to make is this bending jig. And it's going to be mounted on just a piece of, this is about 1/4 inch thick plate. This actually, there was about, I think there's 3 or 4 of these inside the cabinet when I bought my surface grinder. I think they were probably feet pads at one time for feet on a piece of machinery. But of course there'll be a hole in the center of it, counterboard that will screw into the piece we just made over on the lathe. Then these 2 pieces will be mounted with a 3/8 inch gap in between, and using hot material be able to form a circle on in between this. One of the nice things about Hardy tools too is if the anvil is busy or not convenient at the time, you can always mount these Hardy tools in your vise and work with them the same way. These do not have square ends, so I'm going to just carry these over to the lathe and face off both ends of each piece and drill and tap one end for the 1/4 just like I did these. Nothing new on that. And then we'll meet over on the lathe. We'll meet on the mill to drill these holes and mill the grooves into our swage block. All right, the bottom plate for our bending jig is in the mill vise now, and I've got the quill centered up on the very center of this bottom plate. I'm going to drill a 1/4 inch hole. I've got my DRO zeroed out. I'm going to come over a 1/2 inch and re-zero the X. That is going to be the position of our large boss that we're going to mount onto here. And I chose a 1/2 inch just to be sure that both of the clearance holes, both of the countersink holes clear each other. So we'll drill here. Now I took half the diameter of this piece that I just got out of my parts bin over there, material bin. It's just something left over I don't even think it's a nominal size by any means. It looks like it might be about 1.55. And then a piece of 5/8 stock. I took half of this diameter, added it to half of this diameter, and then added 0.375, 3/8 of an inch, which is the gap I want between the two of them. And that comes to 1.475. So from this hole, I'll move over on the x-axis 1.475 and drill our third hole. All right, now I'm going to go get my countersink, and then we'll come back and countersink 2 holes from this side, flip it over, and countersink the center hole from the other side. All right, I'm going to be using these 1/4 inch, 1/4 20 screws, Phillips head, with the countersink head. So I've got the 60-degree countersink in, and this is kind of thin material, but I think I can get the countersink. I think I can get the whole head countersunk without it going through. That was just right. I need to mark that depth. All right, so we'll come over to bring our DRO back to 0. Okay, it's below the surface. Now we're going to turn the piece over. Maybe it won't be too hot. And just simply eye the center on that, which should be about all right, that's below center. All right, I'm going to get the other piece mounted in here, and we'll drill the center hole in it, and then mill our 2 grooves out. All right, I've got our block in that's going to be used for the bottom swage, and got it centered up. We're going to drill a 1/4 inch hole in it, just like we did the other piece. This one, of course, is considerably thicker. While I'm right there, I went ahead and zeroed it out, my DRO. So let's put the countersink in now. All right. Okay, I've got the drill chuck out now and got the end mill, the R8 collet in, and a 1/4 inch end mill. Get that set screw out, or get that 1/4 inch screw out. Now our layout lines are 3/4 of an inch on each side of Y. Come over 750 thousandths. We can get a little closer, keep that quill up as tight as possible. All right, I'm going to zero out the DRO. See the axis right where it touches. I don't want to overdo it by any means. I'm going to start with about 25 thousandths and just see how that goes. Come down another 25. Just don't want to push that little 1/4 inch end mill too hard. Break it off. This is the only ball end 1/4 inch that I've got. All right, one more pass. Will be a 125 depth, which of course is half the 1/4 inch. All right, those edges need touching up just a bit. So what I'm going to do, the depth looks good. I want half the rod sticking out. But the width is not quite right, so I'm going to go down another 25 thousandths. So that's a total of 150 thousandths. Okay, that's much better now. I'll take the file to these edges and deburr them a little bit, and then I believe our 1/4 inch will lay in there good. So I'm going to take the 1/4 inch ball end mill out now and put the 3/8 in. All right, we want to move 750 thousandths on the other side of 0 now, where we can touch off our end mill. 0 out the Z-axis. I believe we can take a little bit more cut at the time now, so I'm going to go for about 40 thousandths at the time. All right, I'm going to go back down to 20 thousandths at the time now, just because I'm getting a deeper cut. $20 thousandths seems to work a lot better on this mill than the deeper cuts do. We're going to start going half of the 375, which is 188, and then fit our rod to it. That's laying in there just perfect. Just a little bit of burr on these edges right here that I'll knock off with the file. All right, I'm going to deburr these pieces, clean them up as far as the dicum is concerned, and we'll meet back over on the workbench and put them all together. Okay, I think we're about ready to wrap this video up, but before we do, I want to answer a question. I've mentioned this in several previous videos, but in the last video where I showed the horn, or in the video where I showed the horn, several folks commented and wanted to know how I got the top flat and so forth. I just put that on the same mill that you just saw me milling the pieces on over there, milling the grooves out, and lined it up as best I could with the length of the table. Of course, this being rough cast on each side, cast steel. Then I took I think I actually used a 5/8 or a 3/4 end mill, and just kept running this back and forth to take that crown out. Railroad tracks have a little bit of a crown in there, so I took that crown out, and then I run the end mill down the sides to get these corners. You can't see it here. I actually left this back edge a little bit rounded, and this a square corner. Then, as I've said in the previous video, I carried it over to the surface grinder, and a lot of overkill, but I set it on the surface grinder and actually ground this top surface up here flat as well. Again, not necessary at all, but I've got a surface grinder Every opportunity I get to learn a little bit more with it, I set a piece up there and grind it. But what we've got finished for today, we got this hardy hole that I made off camera using basically the same principle, turning the horn that I did this piece, turn this cone. We've got the bottom swage with a 1/4 inch and the 3/8 inch track. Again, this will be hot steel pushed on this and forged to form the 3/8 or the 1/2 inch bead or 1/4 inch bead. And then we got the bending jig, and no, it doesn't line up straight. There's going to be a lot of force put on this, so I wanted it tied on the threads. And it really doesn't have to be oriented the same way as the anvil by any means. But what will happen is a hot piece of metal be placed in there and formed, being whatever degree is necessary. If I want a tighter bend, just come around and hold this way. Round rod can be turned or can be bent in it as well. And the gap I left in this was the 3/8 inch. So if you're starting out blacksmithing from a machining background, got a lathe and a mill, here's a simple little way to make you a few hardy hole tools to start out with without any welding or any forging. So take care, and I'll see you on the next video.